plane has taken off the runway and gained a speed of 300 miles per hour, making an angle of 15 degrees with the horizontal. When the plane is 1,600 feet off the ground, a loose nut detaches from the plane and falls to the ground. Neglect air resistance and assume the plane travels in a straight line at constant speed. What is the magnitude of the nut's velocity as it hits the ground? Okay, now to solve this problem, first thing we gotta do is convert this 300 miles per hour into units of feet per second. So we know that 1 mile equals 5,280 feet, and we can go ahead and cancel out the miles, and now we have units of feet over hours. So now we know that 1 hour equals 3,600 seconds, so we can go ahead and cancel the hours. And now we have units of feet over seconds, and now we have the proper units. So because of that, we have to look at the plane is making an angle of 15 degrees, and that means that we're going to need to break our velocity down into x and y components. Now to solve for the y component, we can do sine of 15, and to solve for the x component, we can do cosine of 15. And from there, when we plug everything into a calculator, we get velocity in the y direction is going to be equal to 113.88 feet per second, and the velocity in the x direction is going to be equal to 425 feet per second. Moving on to the problem, it's asking for the nut's magnitude velocity. Now to solve that, we have to figure out what our final velocity is. And because we have our x and y initial velocities, we can go ahead and find the final velocities of the x and y values. And from there, we can do a squared plus b squared equals c squared. Because when we break down our final velocity, we can break that down into our final x velocity and our final y velocity. And from there, we can solve for the magnitude of our final velocity. Okay, so using this kinematic equation, we can go ahead and solve for our velocity final. So we can go ahead and change this to v2 equals the square root of v1 squared plus 2a delta x. From there, we can go ahead and solve for our y velocity. So we have vy2 equals the square root of our initial y, which is going to be 113.88. So 113.88 squared plus 2 times gravity, which is going to be negative 32.2. And we're going to multiply that by our delta x, which is going to be our initial height. So that's going to be 1,600 feet off the ground. And since we're going down from 1,600 feet, that's going to be a negative value. So we have negative 1,600. And when we plug that into a calculator, we get Vy2 equals 340.6 feet per second. Okay, so now we can go ahead and solve for our V final in the x direction. So Vx2 equals the square root of our 425 feet per second plus 2 times, well, we have zero acceleration in the x direction, so we're going to multiply that by 0 and multiply that by delta x. So because this is multiplied by 0, we can completely neglect that, and we just get our final x velocity equal to 425, because this square cancels this square, and that's going to be feet per second. So now that we got that, we can go ahead and do a squared plus b squared equals c squared. So we have our magnitude, and we have our y, and we have our x, and our y is going to be equal to 340.6, and our x is going to be equal to 425. Now we can go ahead and do a squared plus b squared equals c squared. We're solving for c squared, So we can go ahead and do c equals the square root of a squared plus b squared. And when we plug that in, that's going to be the square root of 425 squared plus 340.6 squared. Now when we plug that into our calculator, we get c equals 144.6 feet per second. Okay, so we solved it. And now I'm going to go into a calculator view. So we went ahead and converted our 300 miles per hour into units of feet per second. So that's this part. And then we went ahead and found our x and y components. So cosine for x and sine for y. And then we have our v initial in the x direction and v initial in the y direction. So from there, we can go ahead and solve for our velocities in, or our final velocity in the x and y direction. So we got the v final in the x direction equals 425. And that's because we went ahead and plugged plugged it in to this equation and we solved for v final. And from there, our acceleration was 0. So we got the same as our initial. Do the same thing for our y value. So we went ahead and plugged in our Vy initial. We squared that and then we added that to 2 times gravity because that's the only acceleration going down in the y component. And then we multiplied that by the 1600 because that's the delta x value in the y direction. Now, this was going to be negative, and this is also negative, and then the negatives cancel out, so then we get a positive. And when we plug that in, we get 340.6. And then we can do a squared plus b squared equals c squared to get our final magnitude of our velocity. So when we plug that in, we get 544.6 feet per second.